Hello everyone, welcome again in Eng-Man YouTube channel. So we are going to continue our CO2 sequestration modeling, and we are going to use again CMG software for the CCUS modeling. It's a very powerful software, and we have covered several cases of CO2 trapping, and now we are moving towards a very cool thing, which is mineralization. Okay, but of course we need to deal with the fluid properties first, and that's why currently we are showing the wind prop because we want to deal with the fluid first. All right, so for this, I'm going to use wind prop from the previous case, which is solubility trapping using harvest method. All right, and now I want to, for this, advancement for mineralization trapping, I will just add something like mineral reaction, something like this. Okay, and I will save it as another file to keep my wind prop for solubility trapping only without mineral reaction. Okay, so I'm going to save it as another file. All right. Okay, so from titles EOS unit, we go to CMG GEM EOS model. All right, and then we select GEM here, reactions and or define polymer or non-reacting aqueous components. Click on the button. All right, so it's a very important window for us to model the fluid. Okay, so now we have several tabs. Let me expand this first. I cannot. Right, so here we have no reaction or no reacting aqueous component. We move to this one, reaction selection. Okay, so you need to know that in CO2 mineral trapping, there are some reactions that will be involved. So we need to map the reaction that will be required. We move from the far left, and you see we have reaction type selection. We select aqueous species reaction, and for chemical equilibrium equation derivative, we will use numerical method. Also for mineral precipitation or dissolution rate derivative, we go to numerical. All right, and then for geochemistry database, we will use thermo.dat as the database. And now let's find some reaction for CO2 dissolution. The first one is here. So after CO2 is dissolved, it will be, dissociated. All right, it will become iron after it is dissolved in the water. So I need this reaction. CO2 in aqueous phase plus H2O, it becomes H plus as the, as the positive ion, and this one, the bicarbonate HCO3 minus as the anion. Also, I need this one, CO3 minus plus, hydrogen plus, it becomes this one, bicarbonate. And then I also need reaction, this one. Okay, so this OH minus plus H plus becomes H2O. All right, so that's the first thing, the first reaction. By the way, numerical method is used for calculating the chemical equilibrium equation derivative and mineral precipitation dissolution. So it's very important. Unfortunately, I will not cover the difference between analytical and numerical in this series of video. So you need to study it first. All right, and now let's go to mineral species reaction that will be involved. Again, we maintain everything for numerical, but let's say here we need reaction number 31. Okay, so if you read, about CO2 geological sequestration, you will know that in mineralization, these mineral species reactions will be involved. So there will be, component called anorthite, and also calcite, of course, right? Because, you know, there will be carbonate, there will be calcite here and there. So calcite is very important. And also involved in the reaction will be kaolinite, right? Okay, so 3 reactions involved. You can also select this one and click on that one to move it from the right to the left. And like maybe you can search like this, kaolinite, or maybe let's say kyanite, then it will move. Previous, next, right? Kaolinite, previous or next. You get that? Okay. All right, so that's for the component reaction selection. Now we move towards mineral reaction data.